Hello, this video is a summary of chapter 4 of Business Finance 1 course. The name of our chapter is Time Value of Money. After studying this chapter, you will be able to calculate the future values for single and multiple time periods, calculate the present values for single and multiple periods. You will be able to calculate the present value and future value of investments with multiple cash flows. And you will be able to compare investment alternatives with different compounding periods. And you will be able to calculate loan and payment amounts. This chapter is all about calculations. So we have to use a calculator for our activities in this chapter. I want to remind you that you have to bring your calculators when coming to examinations, but not the ones with the memory inside. So just for just the simple ones, you can use just the simple calculators in the examinations. And this chapter also, the last chapter, covered in the midterm examinations. The first concept is future value in this chapter. Future value is the amount of money in an investment will grow to over a period of time at a given interest rate R. We express interest rate as a percentages, and we use the capital of rate as an expression R. So we will use like present value multiplied by 1 plus R for future value. If we talk about just one period, then we multiply 1 plus R by present value and we will reach the future value calculation. And if we have more than one period of time, so we will have to use another equation. We multiply present value by 1 plus R with n, because n is the number of time periods we have. As you can see in the figure, here we have 12 periods and our n is number of period is 12. Future value and present value are two concepts that are depending on each other. Present value, if we have just one period, we divide future value by 1 plus R. So the equation in the first slide and the second slide actually are the same. Future value is present value multiplied by 1 plus R, and present value is future value divided by 1 plus R. But if we have more than one period, multiple period, then our equation is something like that. Future value is divided by here we add to express number of periods. In that case, in that figure, it is 18. If we have multiple cash flows that can be equal to each other or that can be different. In the first figure, we have 5 different cash flows, which are 1,000, 1,000, 5,000, 5,000, and 5,000. So one by one, we can see the future values of these different specific cash flows. Like fifth cash flow is 5,000, and future value of this 5,000 is 5,000 in the fifth period. We talk about the fifth period when we say future value. Future value is present value for the fifth cash flow. For the fourth cash flow, we have just one time period. So we calculate it like we use the future value equation, and we reach the 5,030 100. In the second figure, our cash flows are exactly the same, and we use the same interest rate for each period, and we reach to future values. The second title is non-annual compounding periods. If we talk about non-annual period, then we have to think about periods which are shorter than a year. If we talk about 6 months, we have 2 6 months in 1 year. So if our interest rate is 10% for a year, then our interest rate for 6 months is the half of the 10%. This is 5%, because we have 2 6 months in 1 year. If we talk about 3 months, then we have 4 3 months in 1 year. So we have to divide this annual interest rate 10% by 4, and we reach to 2.5%. This is the period's interest rate. 3 months interest rate is 2.5%, 6 months interest rate is 5%, and 1 year's interest rate is 10%. In our calculations, we have to deal with that situation by adjusting the interest rate. If our periods are 6 months, then we have to use 6 months interest rate. If our periods are 1 month, then we have to use 1 month's interest rate. How can we find 1 month's interest rate in that situation? If annual interest rate is 10%, then we divide 10% by 12, because we have 12 months in a 1 year. The last topic is loan calculations in that chapter. The borrower pays a lump sum at maturity, which includes the interest and principal. These types of loans are generally encountered for short maturities, usually less than a year. Again, we have to find the future value of a loan to see how much we should repay. And for amortizing loans, we have just like that tables, and in that tables we call it amortization tables. So we see the periodic installments and interest and payment and principal repayment and remaining balance. We can show the calculations and payment structure in an Excel sheet or in any table that we make. This is just to show how much we pay each period, how much we pay principal, and how much we pay interest. Because of the tax considerations, companies report interest payments and principal payments apart from each other. So in each period's payment, we have to know what amount we pay as an interest and what amount we pay as a principal. I hope this video is helpful for your studies.